Alright, this video is on different proof techniques and types of arguments. And so the first one we're going to discuss here is modus ponens. A modus ponens is the classic, most straightforward type of argument. It basically says if you know that P implies Q is a true statement, and you know that P is true, then you can conclude that Q is true. Alright, so if it rains, then you'll get wet, and it rains, then you'll get wet. That's pretty much about as basic as it goes. Its sort of counterpart friend is modus tollens, which is the contrapositive friend of modus ponens. So modus ponens works as the contrapositive would if you say P implies Q, and then you know that Q doesn't happen, you can conclude that P didn't happen. So just like before, if it rains, then I get wet. Well, if I don't get wet, it must not have rained. The next one, so I'm going to come through here, is disjunctive syllogism. And the argument here is that if you have P or Q, and then you know that one of these things doesn't happen, then we know the other one happens. So I can replace, by the way, not Q with not P, and then Q would happen. It's basically the same thing. And the argument behind this is, well, let's say I know I'm either going to have breakfast or I'm going to have lunch. If I didn't have lunch, then I must have had breakfast, right? In order to make this statement true and this thing doesn't happen, the other thing must happen. And finally, the last type of argument is transitivity. And honestly, this isn't necessary by itself as a proof argument. You can conclude this from modus ponens in a sense. But the basic idea is if I know that P implies Q and I know that Q implies R, then I can conclude that whenever P happens, R has to happen. Whenever it rains, then I get wet. Whenever I get wet, I'll catch a cold. So if it rains, I'm catching a cold, right? That's fairly straightforward, and there's not much, I think, controversy about that. And so the way we think about this, if P is true, uh, then Q must be true by modus ponens. And if Q is true, then R must be true by modus ponens. So if P is true, then R must be true. And that's really all transitivity is saying. And in the previous video, I mentioned that we can think of P implies Q as saying that the set of all things that make P true, this is out the set of things that make Q true. Well, if that's the case, and Q also implies R, then this must mean the whole thing lives inside. These are kind of awkward. The set of things that make R true, so if you're in P, you definitely have to be in R, right? So that's all seems straightforward. And then we briefly, in my write-up for this thing, I was kind of very short-winded with this. Those are the things I just wrote down are valid arguments, valid things you're allowed to do. So these are fallacies, which are things you're definitely not allowed to do. So the first one is the fallacy of the inverse. Right? And it says, if you know that P implies Q and Q happens, then P happens. Well, again, in the rain wet example, just because you're wet doesn't mean you know that it came from rain. And sorry, this is the fallacy of the converse. And then fallacy of the inverse is much the same. If I know that P implies Q and P doesn't happen, then I can conclude that Q doesn't happen. That's just bad reasoning too. So let's say if I hit the lottery, I'm gonna be rich. If I don't hit the lottery, that doesn't mean I'm not gonna be rich, right? There are other ways that I could get rich. I mean, not me personally, but a hypothetical me who's not a professor of mathematics could potentially get rich. So you can't conclude not Q just based on not P. So these were discussed in the previous video, but we thought we'd just touch on them as things you cannot do in a process like this. And so a prime number is odd or is true. The prime P is not odd, therefore P is true. Is this good reasoning? Is this a proper use of the logic here? Well, let's take a look. If the prime P is odd, so let's call it being odd A, and is true, we'll call that B, and the prime P is not odd, we'll call that not A. Since being odd is A, then not being odd must be not A, and therefore B. So if we were to write this out formally, we'd say, well, I know that A implies B. And I know, not that A implies B, A or B. I know that A happens or B happens. And then I know that A doesn't happen, so it must be the case that B happens, and this is by the disjunctive syllogism, right? That's the argument we used there. How about this? If I read the handouts and I watch the videos, then P, I will pass the class. And so, let's say, so let's write this out. If I read the handouts and watch the videos, then I will pass. I didn't pass. I read the handouts. I must not have watched the videos. All right, so let's think for a moment and see if this is at all reasonable. This is in the handouts too, by the way, so even though the handwriting here is pretty bad, you can follow along with that. So I'm going to go ahead and erase this, and let's write down on the side here what we actually know. We know that if I read the handouts and I watch the videos, then I'll pass. I also know that I didn't pass. I also know that I did watch, uh, I did read the handouts. So I'm trying to see if not V happens, if I didn't watch the videos. So I need to start breaking down some sort of statement about H. Now H lives inside of this nested thing, which lives inside of that thing. And so it's hard to get at H directly. I could try to suss out some statement about this. So, sorry about V. Like V lives inside of this, lives inside of that. I do know H is true. So if I look at these two statements together, it's not really much I can do about that, right? There's no rule we have where I can connect H to anything that's happening here. I also don't really have a rule connecting not P and H. They're totally just separate statements. But if I look at this, not P is the negation of one of the arguments in this implication. So I can start with that, right? There's nothing I can do here, there's nothing I can do here, but there is something I can do here, right? With these two statements here. So I know that H and not P, or H and V implies P. I know not P. And therefore, by modus tollens, I know not H and V. I also know that that's equal to not H or not V by De Morgan's law, right? So now I have this statement. This is a list of facts, part of my list of things that I know. That not H or not V happens. And then I know that H happens. And so now I get to use the disjunctive syllogism as well, right? So in a new argument, I say, well, not H or not V happens. And H happens. And H is not H, isn't it? So that means this is false, right? Not H is a statement I claim, might be one of the things that happens, and I'm saying it's not happening. So the other thing that could happen is not V. So by the disjunctive syllogism, what we get as a conclusion here is not V, and therefore, yes, I can conclude that the only way that this could have happened is if I didn't watch the videos. Now let's see if this makes sense in original context. If I read the handouts and I watched the videos, then I'll pass. Well, let's see. Let's get rid of all of this. We didn't pass, right? So that's false. So the only way that this whole statement here could be true is if this statement here were false, right? But this statement's true, right? That's my H. I do not read the handouts, so it must be the case that that guy there is false, and therefore not V is true. All right.